Today we will solve this differential equation using power series solution. So this y double prime is equals to y is equals to y double prime minus y is equals to 0. So let y is equals to summation n is equals to 0 up to infinity cn x raised to n. For us to get the y prime, we derive this equation. So we come up with summation n is equals to 1 approaching infinity and cn xn minus 1. To get the y double prime, we also derive this equation, so we come up with summation n is equals to 2 approaching infinity m times n minus 1 cn xn minus 2. So we substitute these values to this equation, y double prime minus y is equals to 0. So we come up with y summation n is equals to 2 approaching infinity n times n minus 1 cn x n minus 2 minus summation n is equals to 0 approaching infinity cn x raised to n is equals to 0. To solve this equation, we need to have the same index. Since we don't have the same index, we need to deduct 2 here for us to subtract 2 here, so we come up with n is equals to 0. Subtract 2. So since we subtract here in the index, this expression, we need to add 2. So n plus 2, we come up with n plus 2. Here, negative 1 plus 2, so we come up plus 1. So here, cn plus 2, we get here. So in this area, we need to add also 2, so we come up with x and x raised to n. So since we have the same index of this expression, we can now factor out the summation n is equals to 0 approaching infinity. So we have summation of n is equals to 0 approaching infinity times n plus 2 times n plus 1 cn plus 2 minus cn times x raised to n is equals to 0. So we are now have our recursion relation formula. To simplify this equation, we come up with cn plus 2 is equals to cn over n plus 2 times n plus 1. So we have now our recursion relation formula. So we now need to substitute the values of n to our recursion relation formula. So our recursion relation formula, cn plus 2 is equals to cn over n plus 2
Since
times
we
n
have
plus
now
1.
our recursion relation formula,
We need to substitute the values of n to our formula. So we have n is equals to 0, so we have c0 plus 2 is equals to z0 over 2 times 1 is equals to c2 is equals to c0 over 2 factorial. So here we have n is equals to 1, so we have c1 plus 2 is equals to z1 over 3 times 2 is equals to c3 is equals to c1 over 3. So we now have n is equals to 2, so have c2 plus 2 is equals to c2 over 4 times 3 is equals to c4 is equals to c0 over 2 factorial over 4 times 3, which is equals to c4 is equals to c0 over 4 factorial. Next, we have n is equals to 3, so we have c3 plus 2 is equals to c3 over 5 times 4, which is equals to c5 is equals to c1 over 3 factorial over 5 times 4. So we simplify this, we have now c5 is equals to c1 over 5 factorial. N is equals to 4, so we have c4 plus 2 is equals to c4 over 6 times 5. We simplify this, we have now c6 is equals to c0 over 4 factorial over 6 times 5. We simplify this, so we have now c6 over is equals to z0 over 6 factorial. And last, we have now n is equals to 5, so we have c5 plus 2 is equals to c5 over 7 times 6 is equals to c7 is equals to c1 over 5 factorial over 7 times 6. We simplify this expression, we come up with c7 is equals to c1 over 7 factorial. As we simplify this equation, we come up with this simplified formula for even and odd numbers. For the even, we have c2n is equals to z0 over quantity 2n factorial. For the odd, we have C2n plus 1 is equals to C0 quantity 2n plus 1 factorial. Simplifying this equation and substituting all the values, we come up with y is equals to C0 times 1 plus 1 over 2 factorial x squared plus 1 over 4 factorial times x raised to 4 plus 1 over 6 factorial x raised to 6 plus so on and so forth plus C1 times x plus 1 over 3 factorial x cubed plus 1 over 5 factorial x raised to 5 plus 1 over 7 factorial x raised to 7 plus so on and so forth. As you observe, this expression 1 plus 1 over 2 factorial x squared plus 1 over 4 factorial x raised to 4 plus 1 over 6 factorial x raised to 6 is equals to hyperbolic cosine x. So we simplified this to C0 cosine hyperbolic cosine x. And this expression x plus 1 over 3 factorial x cubed plus 1 over 5 factorial x raised to 5 plus 1 over 7 factorial x raised to 7 is equals to hyperbolic sine x. So we simplified this equation to the transcendental function C0 hyperbolic cosine x plus C1 hyperbolic sine x. So the final solution of y double prime is equals to y is equals to C0 hyperbolic cosine x plus C1 hyperbolic sine x.